discussion. I have most of it done, but I just had a question about using what is it? The proportion stats with one sample. I'm having trouble using the data that you provided, but I have the proportions of African American inmates to the total number of inmates. So do you want me to try to use it with the data or just with the numbers that I got from it?
Yeah, I think all you need to do is, it's kind of like the very first video you watch in this chapter to just do it with summary. Because all you need to know is the sample proportion to do the analysis, which you already have, right? What sample proportion did you have? About 20 some percent?
Yeah, it was more like 29. I got 120, I think, out of 480.
Okay. So then you take that as your sample proportion and do a stat proportions, one sample with summary, and I think you got it then.
Okay, I just didn't know if I was okay with just the summary.
Yep, that's all you needed. So you're essentially given that aggregate data to have a larger sample than what you took just on your own, and then to do the analysis with a sample size of 300. What's interesting is you get a margin of error, I think around 4%, 5%, something like that. And if you do I don't know if you've done the ones where sample size required, to get like a 3% margin of error, you need to have like 1,000 pieces of data to get that margin of error down to about 3%. But this is like 300 some, so I think it's like 4 or 5% margin of error. But yeah, so you just use StatCrunch, use a summary of that. That's all you need.
Okay, I think I got the discussion pretty much all done then.
Cool. Yeah, and it's the same, like you can even do like confidence interval or hypothesis test in that same area, right? You can just check the other box, and yeah, and what I really like is if you could put a little screenshot of your work, just showing the little, here's what there's what I put in StatCrunch. Because lots of times I'll get some weird answers and I'm like, I have no idea how they got that answer. So then usually I'll reply, hey, can you do that part again or whatever? Can you show me how you got that? But a lot of people, I'd say some of the superior posts are the one who just take that little screenshot of what they did in StatCrunch, so it kind of shows exactly how they did it.
Okay.
Yeah, you don't have to, but man, it's nice. In case you make an error, then I can look at, oh, that's exactly what they did. So that's a good one. So yeah, I've had a few people email me that question. They're like, I load the data in StatCrunch and it doesn't really work. I'm like, well, you don't really need to do that because you're just looking for a raw proportion. You just need to look at the data to find that sample proportion and then you just go ahead and do your analysis.
That's what I figured. I just wanted to make sure I wasn't doing anything wrong.
Nope, that's great. Hopefully that will, and I've recorded this too, so hopefully that will help a few people that are be working on here the next day or so. All right, how about Megan Beener?
Okay, I was curious. I have like a couple things that I didn't know what to do. So for the confidence interval, I don't understand how to like find that.
So you can use, you got the formula sheet, right?
Yes.
Okay, so there's a couple ways to do it. I'm just gonna do one by hand and then I'm gonna encourage you to StatCrunch after that, okay? So do you have an example of one you're working on right now?
Yeah, so I did it in StatCrunch.
Okay.
And then
what was
I just
your
didn't
sample
know
proportion?
Hold on, let me find it.
So we call your sample proportion, we call p hat.
Okay, so I had it was one where it's like you have to do two of them.
Okay.
So I had like 1436 for the first one with the 416.
Whew, two C's, sorry. All right, say that again.
So it's like the total is 1436, and then the count would be 416, and then the total of the second one was 745 with the count of 213.
So, and what was the second one again?
The total of 745 and then the count of 213.
All right, cool. So there's your two sample proportions, right?
Yep.
And then, so like, did they want you to find a confidence interval for the difference between the two? Is that
It
section 9.1?
says yes.
Section 9.1.
So yeah, it says the 99% confidence interval is blank greater than P1 minus P2 greater than, or
so you're trying to find
blank.
the difference. Yeah, the difference in those two. So
Okay.
let's see what's 416. 416 divided by 1436. Is that what it is?
Yeah.
0.2897, something like that.
Okay.
Now the great thing is StatCrunch will keep track of it exactly, but I'll just put what I have. What was it again? 0.2897.
2897.
Yeah. All right. And then the other one is what? 213 over 745.
Yep.
So that's 0.2859.
Okay.
So not a lot of difference, is there?
No.
So they want you to create a 99% confidence interval for the difference in proportions. So if you look at the formula, it's P1 hat minus P2 hat plus or minus Z. And then you've got this kind of ugly calculation of P1 hat and then 1 minus P1 hat over N1 plus, I do the other one, P2 hat 1 minus P2 hat over N2. So there's the manual way to do it. If you're doing a 99% confidence interval, what's your Z multiplier there? Is it, do you have that right in your formula sheet? Is it 2 point?
I'm not sure.
It's right,
Where would
it's
I
right at
find
the
that?
top here. On their formula sheet right at the top. It says confidence intervals with all the multipliers. It's like 95% is 1.96, and this is 99%, right?
Yeah, so where's the formula sheet? Sorry.
Oh, okay. So on Blackboard in course content, and you can
Okay.
go to this week's week 9, right?
Okay.
And it says statistics formula. Oh, I had it open last week, but I don't have it this week. I thought that was. Oh no, am I looking in the wrong folder? So this manual method, which I'm showing, is and then you can do it StatCrunch too, but I'm just showing both. All right, do you see it now? In week 9.
Yes.
In fact, yep. So right at the top there, do you see where it says for the Z multiplier for 99%?
Yeah, so the 2.575.
Yep, very good. And I'm not going to go ahead and write all that out, but essentially what you're doing here is you're going to take the difference of these two proportions, which is the difference between these two, and then you have the Z multiplier times this. This is what we call the standard error, the rest of this calculation, and everything to the right here is called the margin of error. But in StatCrunch, you just go stat proportions, right?
Okay.
And you have two proportions, right, or two samples.
Yep.
They're not. Yep, and then with summary.
Okay.
And then you should be able to type in the 416, the 1436, the 213, the 745, and then make sure you have 99% confidence selected.
Okay.
and then hit compute. And what do you get?
So
I might pull this up too. I might just show that. Get my StatCrunch open here real quick.
what would it be under?
It's under, let's see here. So go under stat.
So I
I'll
have
just
like,
show it right here.
yeah, so like
Let me
I
show
did
it
it,
here.
but then it says like sample difference, L limit and U limit.
Yep, your lower limit, upper limit, that's your confidence interval.
Oh, okay, perfect.
Yeah, I'll just show it here real quick. All right, so do you see that?
Yes.
So you go stat, and then you go to proportion stats, to sample with summary.
Okay.
Cool.
Okay.
And then what was the number of successes in the first one?
It was 416.
416 out of,
1,436.
there you go. And then the other one was what,
213 out of 745.
Thank you. There we go. And so you can do a hypothesis test. Your null hypothesis typically is that they're going to be equal. The alternative is that they're not. In this case, we're doing
Okay.
confidence interval. So I'm going to change that to 99% confidence.
Okay.
And compute. So we are 99% confident. The true difference in proportion is between negative 0.048 and positive 0.056, which tells
Okay.
me it's very possible that the true difference in these proportions is 0, right? We don't, well, one's negative, one's positive. That tells me 0 is in the interval. That would probably reinforce that there's not a significant difference between these two. If I want to do a hypothesis test, let's go ahead and do that right now. I can just hit edit here. It's already got the data. I'm just going to click hypothesis test. Null is equal, alternative is not equal, and just hit compute.
Okay.
And there it is.
Yeah.
Get a
Okay.
very
So I
small
got
z-score. And, yeah.
Okay. So then
Yeah, so it kind of
the
reinforces that.
confidence interval would just be your low and your upper.
Yep.
Okay.
And make sure you
Perfect.
round it to the right number of digits there that they want
Okay.
in their input. So
Okay.
is that helpful?
Yes, that was very helpful.
Okay, cool. And I'm sorry I didn't have that open. I'm very sorry about that.
No, you're okay. And then I was just
So
wondering
I would
how
encourage
to
you just do these on StatCrunch like we just did. That's completely
Okay,
fine.
yeah, I will
Okay.
for sure. And then
Yep.
I was just wondering how to find the test statistic on just like one sample instead of two.
So if you just wanted to find is it for this problem or a different one probably?
It's a different one. Let me see if I can find it.
Yeah, probably from a different section. So you can do the same thing here. I'll just make one up real quick.
Okay.
Let's say the null hypothesis is, what's the scenario? Did they give you on this? Did it give you one?
Yeah, hold on.
So all you just go stat, proportion stats, one sample with summary.
Okay. So for this one, it says suppose 250 subjects are treated with a drug that is used to treat the pain and 50 of them develop nausea. Use 0.05 significance level to test the claim that more than 20% of the users develop nausea.
So your null hypothesis is that it's 20%, right? So you see how I typed that in right there?
Yeah.
The alternative is that it's greater than 20%, right?
Okay.
And then what was the sample data? How many out of how many?
250 was subjects, and then 50 of them developed nausea.
So 50 out of 250?
Yep.
As you can see, it's exactly the same because 250 out of 250 is 20%. So that's a z-score of 0.
Okay.
And so, yeah, there's obviously it reinforces it's exactly 20%, exactly the same.
Okay.
Does that
Yeah.
Was that the correct, was that the sample they gave you was exactly the same as the population or
Yes.
what they thought it was?
Yeah.
Okay, cool. Well, that's not a super exciting problem, but
And then the last one I had a question about was the number 9 and 10 for 9.1, which is
yep,
like the how do you find the sample should include how many men and how many women.
yes. Okay, so the sample size required, is that what they're asking?
Yes.
Okay, I'm gonna hit stop sharing here. All right, this is where that formula sheet I just made available to you makes it easy to find these formulas. I mean, you can find them in your
Okay.
book, but that's kind of a pain. So I'm gonna go ahead and pull that up real quick, okay?
Okay.
And let's see your classes top. All right, so here's that. Hopefully you can get it. All right, do you see that?
Yep.
Do you know how to zoom in the upper left-hand corner? There's like magnifying glass, you can make it bigger.
Yeah.
Okay, so right here, sample size needed where error E is the maximum error estimate. So what's the situation they give you?
Says oops, um so like the difference between men and women who own smartphones, and then it says assume that 90% confidence that your error is no more than 0.04% or
All
0.04.
right, so if we look at this, we're doing it for proportions, right?
Yes.
So let's go ahead and use this formula here. So N equals, now do we have any idea historically what the proportion is? Does it give you anything? I don't think I heard anything.
It just says assume that you want 90% confidence.
Okay, so if we don't have, like if they could have said like historically the proportion is 20%, then you could use 0.2
Yeah.
here. But if you
Okay.
don't know, you just use 0.5.
Okay.
So P is 0.5, 1 minus P is also 0.5, right? So that's 0.25.
Okay. Yep.
And then Z, 90%. So what is the Z score for 90% confidence? That's right at the top of that formula sheet.
It would be the 2.575.
That's for 99%. What's it for 90%?
90. 1.645.
Very good. And what's the error they said?
0.04.
0.04. So within a 4% margin of error. So there is
Okay.
your formula for it. So pretty much you punch that in your calculator. So you put 1.645 divided by, I'm going to do that right now. 1.645 divided by 0.04, which is like 41.25, and then you're going to square that.
So 1691.27.
Yep. And then you take that times essentially 0.5 times 0.5, which is times 0.25, right?
Yeah. So 422.82.
Yep. So your answer, you would need to have 400. You always have to assume one more if there's anything over. So it's going to be 423.
Okay.
So you're going to need a sample size. You need to at least get 423 for your sample size to have a 4% margin of error with this level of accuracy.
Okay.
Cool.
So then, so then how do I find out how many are men and how many are women?
It doesn't matter. You just need 423 subjects total to get to. So like if you're trying to find, if you're testing for the proportion of men and women with other whatever thing you're looking at, you just need to go out and randomly find 423 people, and then So
So it can just be anything that adds up to 423.
yeah, so it's not, I think in this situation they were I don't know what was the question they were going to ask or something.
It says this sample should include blank men and blank women.
Okay. Does it say anything before that, like they want to be even or something?
It just says use the expression in the accompanying discussion of the sample size to find the sample of each sample. If you want to estimate the difference between proportions of men and women who use smartphones, assume that you want 90% confidence that your error is no more than 0.04. And then it says click the icon to view the discussion of sample size.
Okay. Yeah, I think go ahead and type in 423 and see what happens.
For both?
Yes. I'm curious. I'm going to look at this. I'm going to look up this one real quick.
It says that one or more of your answers is incorrect.
All right, I'm actually going to jump to this problem. This is 9-1 number 9, you said?
Number 10.
Number 10, okay, let me look at it. Mine's a little. They've got a little different formula for this one, not much different. They're squaring. Let's see here. They're taking yeah. So I think they may have done, since it's a slightly different formula. So you put 423 in for each, is that correct?
Yeah. Yeah.
Let me see here. I'm actually going to do this one real quick. Hold on.
So it says that it would be.
I think you have to double them for each. I think you have,
Okay,
so
yeah,
take
846.
423. So that'd be what, 846?
Yeah, it says the correct answer is 846, 846. So basically,
Yeah.
just
So
do
essentially, since you're doing a difference of proportions, you need twice as many to accommodate the potential for double the error. Yeah. So you just take that same formula, but you got to double it.
Okay, perfect.
That's a little different. Yeah, that's kind of a weird one.
Okay.
That's a good question though. That tells me are you done with your homework then?
Now that I know how to do it, I can finish it. Yeah.
Cool. Yeah, you must be close if you're doing those. So.
Yeah. Well, I kind of started on 9 to see if I could figure that out before 8, but yeah. Okay. Thank you.
Okay. I'm just checking an email here from a student. No worries. All right, cool. All right, let's go back to the list here. So Nicole, I saw you're having some issues joining. Thanks for persevering. What are you working on right now?
Hi, sorry, I'm battling some kids right now, as always, so you'll probably hear them.
That's right.
It's my life every time I hop onto one of these. So I, when I was doing 7-1, I realized too late that I was doing things manually that can be done in StatCrunch. I just got so focused on figuring out how to do it that I totally forgot that in the video she was like, and you don't have to do any of this manually because you can do it in StatCrunch. So I spent a ton of time on that and got a little behind. So I'm still trying to figure out 8-1.
Okay. Which one are you on?
It's just it's really confusing to me. So if you could just of the steps of figuring out that stuff, that would be the most helpful to me. Is I don't know, maybe just a different wording from the video I've watched twice.
I was thinking I could just pick one of them and just walk you through it and explain it as I go.
That's literally what I think.
I clicked on number 6. Is that an okay one?
Sure, go for it. Yeah.
8-1. All right. So I'm just going to share my screen, okay?
Thank you.
And walk through this with you. Yeah, no, this is good. Let's see here. Share my screen. Here we go.
Bye, baby. Love you. It's my class. Oh, I'm sorry. I'm not muted. My bad. Hold on.
Oh,
I'll
that's
mute.
all right. That's so cute. I love it. Let's see here. Number 6. Here we go. There. Can you see that?
Yes.
Okay. The standard deviation of pulse rates for adult males is less than 10 beats per minute. For a random sample of 136 males, the pulse rates have a standard deviation of 9.6 beats per minute. Find the value of the test statistic. So I'm in the wrong section, maybe? No, I'm in the right section. Yeah, 8-1 you said, correct? So this one, I don't know, again, I don't know if you can. So the reason I don't like this problem, because it makes it, they're actually trying to, they're doing a claim on standard deviation here, but it should be test for means. That's why this one's a little weird. This is probably not a good one to start with. Now I want to do one with real data. Let me find a better one here. No, they give you, I want one that I have to do everything on. Yeah, they're giving you, yeah, no, maybe I need to go backwards. All right, I'm going to close this. Hold on. Sorry. Let me go back to 1 here. It's probably a better one to explain all this. This, oh, is the wrong section. This is the wrong section. All right. 8-1. So 8-1 is the basics of hypothesis testing. So what you're doing here is you're trying to either use means or proportions. In this case, you're going to be doing proportions of comparing either one proportion to what you thought it should have been, or in section 9.1 we'll do proportions comparing to each other. So our null hypothesis is always equal. We think that it should be equal to this number. So, and this one says a majority would erase all their personal information. A software firm of 406 randomly selected adults showed that 56% of them would erase all their personal information. So we've got a sample proportion here, but it says a majority of adults. So that means it's over half. So our null hypothesis, and we're talking about proportions, is, let's see here, the original claim in the symbolic form, P equals 0.5. See if it likes that. Nope. Oh man, I don't like the way they're doing this. They're going to say it's greater than. Yeah, that's bad. Because whenever you really do a hypothesis test, this should always be an equal sign. The null hypothesis is really what this is trying to get you to understand. Let's see if it makes it. Let's see if it figures it out in this one. I'm very curious, see if it figures this out. And then the alternative is that it's greater than 50%. See if it likes that. Yeah. So this is why I don't like that first part, because honestly, these should match. Oh, that's all they wanted? Okay. Well, anyway, let's let me go back to that one again. So if we actually wanted to find this test statistic, we want to find the z-score. The formula is z equals p hat minus p over the square root of n times p over q. Or we can just use StatCrunch. So I'm just going to go ahead and open up StatCrunch in this one. And let's do a one sample z test for proportions. So stat proportions, one sample with summary, because we're only given one set of sample data. The number of successes was said 56% of 406. So what's that? 0.56 times 406. Of course, that's a bogus number. So we'll do our best because it's 227.36. So let's go 228 because it's got to be a discrete number. Number of observations was 406. The null hypothesis is P is equal 5. Our alternative is that it's greater than 0.5. That's what we had. And hit compute. So our z-score there is 2.48. P-value is 0.0065. So this shows us that the sample proportion is significantly higher because the probability of getting this result by random chance is less than 1%. So that means it is the survey would say, you know what, it's probably higher than 50% based on their people they surveyed. So we would reject the null hypothesis and say there is significant evidence to say a higher than, or more than 50% of people would erase their personal data if they could. Was that kind of what you were looking for?
Yeah, that makes sense. And seeing it walked through on StatCrunch helps too. Just
yeah.
It's the hardest thing I think for me in all this is getting the terms right and like knowing the language of like what it's asking for, and yeah, that's the hardest part. And so it helps seeing it.
Did you? I did. There. It's a 25-minute video of me just talking about hypothesis testing, and I talk about the example of the criminal case. Did you watch that one?
I did not watch that one.
Okay.
I watched the lecture video. I think I just thought that 7.1 was done, so I just skipped down to 8.1 and I just went right to the lecture, not even looking at that. I watched the lecture one like twice fully through, but yeah, I haven't watched this, so maybe that would probably be helpful for me in this too.
I mean, you might find it interesting too, because I use the analogy of someone is innocent until proven guilty.
Sure.
So the null hypothesis is they're innocent. The alternative is that they're not innocent, which we call guilty. But to prove that they're not innocent, you have to have significantly different evidence of their innocence, right? You have to be far away. So you have to, the standard in a criminal court is it has to be beyond a reasonable doubt, right?
Right.
Which is the probability of you making an error, which is a type 1 error, which is rejecting the null hypothesis, which was they're innocent. You don't want to mess that up. You don't want to make a type 1 error. You don't want to send an innocent person to prison. So the alpha level is super small. That's just, we want 0.00001% of the innocent people to go to prison, right?
Right.
So the standard is super high. In a civil case, it's not as high, right? All you're going to lose is some money. So the standard is different. That's like how your alpha level changes. The more heinous it is to make a type 1 error, which is rejecting the null hypothesis and you're wrong, the smaller you want your alpha level.
That makes a lot of sense. I remember reading about, it said something about with high stakes, but that example makes that make more sense.
So let's see if it's really hard to put innocent people in prison, what would be the potential negative result of that?
If it's hard to put innocent people in prison?
Yes, it's very hard to put innocent people in prison, which it is in the United States. It's very hard to put innocent people in prison, which is good.
Well, maybe that it's also hard to put guilty people in prison?
Yes, so then you end up with a lot of guilty people walking the streets because the burden of proof is very hard.
Sure.
But that's what we call a type 2 error. Type 2 error is when you fail to reject the null hypothesis, but you should have.
Yeah, that makes a lot of sense.
But that's more palatable, right?
Yeah.
When somebody's guilty and gets off, okay, we might hear a story about that. But when an innocent person gets exonerated, right? They were innocent, but they were found guilty. They made a type 1 error. That
and they spent like 20 years in prison, or
yes, that's on Dateline.
Right. Yes.
So that's a bigger deal.
Yeah, that makes a lot of sense.
So you're like, okay, no. We want less guilty people walking the street. Well, that's called type 2. We want fewer type 2 errors. Well, if you lower the type 2 errors, the type 1 errors go up. They kind of they balance each other out. Now, what can help both is better methods, more accuracy, more data, less variability. So if we're like CSI has helped variability, there's less variability. So now you could potentially lower both type 1 and type 2 errors if you have a better process, which is, if you think of manufacturing, you don't want to make bad parts, right? So, but if you improve the process and have less variability, you have less error, the better your process is. Same thing with the court, any process. Sometimes this is a little earth shattering because, like, do engineers have to think like this? Yes, they're building an airplane. They have certain tolerances that they do things within. There are potential mistakes, right? There's variability with everything. The question is, does the variability get so much that something catastrophic happens? Which is why you want to, like, they over-engineer airplanes, right?
Sure.
They probably don't over-engineer this water cup because, I mean, really, what's the catastrophic thing that's going to happen? I might spill.
Right, and like the parts that make the airplane move and fly are probably much more engineered over the seats or the
exactly
the TVs on the back of the seats, right?
So I think that helps you understand alpha levels then, right? The alpha level is just the probability, or essentially what's the acceptable amount of type 1 errors you're willing to have. That's really what you're saying. So if someone says 0.05, I'm like, I'm okay with being wrong, making a type 1 error, false, rejecting null when I shouldn't have 5% of the time.
Right.
So it
that makes a lot more sense.
Yeah.
Context helps.
Context is that's why all these problems are typically in context. I had an interesting conversation once with a woman, this is actually in Jamaica. Her and her husband were there, and I was there with my wife, and she was a cancer researcher from Johns Hopkins University. And I go, oh, I teach stats. She goes, oh yeah, we do a lot of stats because we're, I go, what's the alpha level you use? And she goes, she probably doesn't get that question every day, but she goes, I think she said it was like 0.15 or something like that. I was like, ooh, that seems pretty high. You're going to make type 1 errors. She goes, yeah, but we're working with stage 4 cancer patients. We're trying to find anything that will help them. So our tolerances can be different. It's not like you're making aspirin where it's like not a deadly thing, right? But we're working with life and death. So we have different standards by which we would say what is safe and effective, right? Does that make sense too? Anyway, I thought that was kind of interesting. Another scenario that I talked to somebody about. But so yeah, if you're gonna do these in StatCrunch, I'll show that really quick. So again, stat, you can use proportions, or if it's this next week, we're going to be using t-stats with means. That's next week. But right now, you're pretty much doing proportion stats this whole time. It's either 1 or 2 samples, and pretty much all of them are with summary. And then you can just put the number of successes out of how many, do a confidence test or hypothesis test, and you're done. And then interpret the results. Ooh, let me stop sharing here. All right, so is that helpful? So Nicole, what I would suggest is homework's due tonight. So, hammer through them, use StatCrunch to do your analysis, and you'll be fine. And then the discussion is due tomorrow, which we talked a little bit about before, but that shouldn't be too bad now, especially if you've done the homework. It's just like one homework problem, but it's based on that same discussion we've been doing.
Yeah, that sounds good. I tend to like something will just click, and then I'm like, oh, I get this, and then I can hammer through 10, 20 problems and I'm fine. But it's the grasping the concept in the beginning that makes me feel like, oh, I'm not cut out for this. I can't do this. So hopefully this goes a little bit smoother now that I've got a little more context and I can understand it a little better. That I'll get through this a little faster. I appreciate your help.
Yeah, and this, the way we're talking right now is the way we'll be talking for the rest of the course. So what you're learning right now is kind of the heavier lifting, and then this is just, so the next week is the same kind of talk with means, and the next week is the same kind of talk with deviations, and then the last few weeks are with, you do a little linear correlation and then your project. So from now on, this is the way we're describing scenarios. Here's
Well,
what I
and she
think is
said
going
in the
on.
lecture that this is like, these are like some of the hardest chapters in the whole course, which makes me at least feel
Yes.
better, where I'm like, if I can master this, then I can do the rest. It's not just progressively harder
Yes.
and harder and harder.
No, these 3 chapters are the hardest. So if you put your time in now, do what you're doing, learn it, and honestly, you're gonna have no trouble with the final or the project, which is another 25% of your grade right there. So if you do good on this exam, you're gonna be just fine. Yeah. So, and when we get closer, you'll see how I organize. Like, I really only asked 4 or 5 problems over this content, right? Because step 1, what's the null and alternative hypothesis? Step 2, what's your test statistic? Step 3, what's your p-value? Step 4, what's your decision based on that p-value? Step 5, what's that mean in context? I can even add a step 6, say what's the type 1 and type 2 errors? That's a whole bunch of steps for one scenario, which you're starting to do. I mean, I can only ask like 1 in proportions, 1 with maybe 2 proportions, 1 with 1 mean, maybe with 2 means, 1 with deviations. That's the only types of problems there are, but the thinking that we're doing is applied to everyone moving forward. Here's what I think is going on. I go get some data. Based on that data, does it kind of back up what I thought, or does it refute it? What evidence do I have? What does that say? What does that mean? What are the type of errors I could be making? That's the statistical thinking that comes along with all this. But it's kind of cool. You can actually take data and analyze it now. All right. So Nicole, if you hit some, what you're doing tonight, hit that Ask My Instructor button. I'll be on tonight helping as well. I wonder if somebody asked, I might have another office hour later. I offered it to somebody if they wanted it. Maybe not. Maybe not.
Yeah, I'm headed to an appointment now, but after that, I'm going to a coffee shop. My husband's got my kids, and I'm just going to work until I get it done. So hopefully I can get it finished tonight. But if I end up in tears, you may hear from me.
That's be fine. Give me a call. All right, keep up the good work. All right. Megan, did you have another one that you wanted to go over?
Yeah, I just had one more real quick
Sure.
question.
Yeah.
So for the discussion for number 2, I know that claim would be the alternative hypothesis because it doesn't contain an equality. But what I'm wondering is, with the wording of the claim, I'm wondering if it should be an inequality or the proportion is more than 7.2%.
Yeah, so your null is that it's equal to 0.072, right?
Yeah.
And your alternative is that it's probably greater. That's
Yeah.
that's the part. Yeah, that's what we'd be worried about.
Okay.
And it is very much different, isn't it?
I'm just wondering, like, with the wording of the claim, like there's a disproportionate number.
Yes.
I didn't know if disproportionate pointed to it being more than or just not 7.2%.
Yeah, it could be a two-tailed test, right? You could have a disproportionately low as well, but obviously in this case we're looking for, it's the sample data is like 20 some percent, so
Right.
it's definitely higher, you know. Yep.
Okay, that was my last question about that.
Cool. All right. Well, good job. Thanks for being here today. I'm going to post this recording as soon as it's done processing, and I'll blast that out to everybody.
Thank you so much for your help.
Oh, you're